Okay, a couple of examples that, we did go over examples like this last time. You find them in the text and so forth, but I think that they're important examples because this is exactly how you apply the formulas, okay? So first place. Find the derivative of f with respect to t because t causes x to change, which in turn causes x squared over y to change. Okay, so t causes x to change at this rate, and x causes f to change at this rate. If you multiply the two rates, you find out how much f changes with respect to t because of the x function. And then the same thing over here because of the y function. T causes y to change at a certain rate, which is dy dt. And then y causes f to change at a certain rate, which is df dy. And if you multiply the rate at which y changes with respect to t by the rate at which f changes with respect to y, you find out how much f changes with respect to t because of y. Now, it's worth digesting that whole statement, which you won't have picked up instantly in your brain unless your brain is totally wired, okay? And you already pretty well understand a lot of it. Still, it's a formula. You write it out. And what I just said helps in remembering how to write out the formula. Okay, what's df dx? It's 2x over y. What's dx dt? It's 3 e to the t. What's df dy? It's negative x squared over 2y squared. So it's negative here. And dy dt is 5 e to the t. Okay. Now, of course, x and y can be expressed in terms of t. So this is 2 times 3 e to the t over 5 e to the t minus quantity 3 e to the t squared over 2 times 5 e to the t quantity squared times 5 e to the t. So we can take that out and simplify it in the algebra for a second. Okay. Also, alternatively, f of x y is x squared over y. Well, x is 3 e to the t, so that's 3 e to the t squared over y, which is 5 e to the t. Okay. Which is, well, you're going to get 9/5 e to the t. Then you can algebra simplify. Going to get an e to the 2t when you square e to the t. You're going to divide that by e to the t, which is going to leave you with e to the t. You're going to get a 9, which is going to 3, get 5 there. And the FDT is then 9/5 e to the t. Now, in this case, this is direct substitution. This is what I mean by direct substitution. We just substitute the x function for x, substitute the y function for y, and you get something. It's really easy to take the derivative of. Now, this is a little more involved, but it's going to come out the same if you do it right and if I did that right. Okay, that's all that's meant. It means that it's totally equivalent, that this is totally equivalent to what you get if you just plug it all in and get a function. Sometimes that's inconvenient. Sometimes this is more convenient than this. In this case, this would be more convenient than this, but this tells you more than this does. Okay, so that shouldn't be too difficult. Okay. Now, how do we get dy dx? How do we use implicit differentiation? Okay. So that the differential df is fx dx plus fy dy. Fx equals this, and we just do the differential of this. And of course, the differential of this side would be 0, right? So what's our derivative with respect to x? Well, fx is 2 times the cosine of 2x plus 3y. What is the dx? And then fy is this. I forgot my new slide. Maybe the zero is not getting obliterated. Now I'm going to skip an algebra step, simple algebra step. We just add this to both sides. Okay. And then we divide both sides by this. Maybe I should do the intermediate step. That doesn't do a good job. There should be a negative on the side. Well, we divide both sides by dx, and then we divide both sides by this coefficient, and we get negative 2 cosine of 2x plus 3y over 2 sine of 3x minus 2. Implicit differentiation, which is something you might want to review from Calculus 1. Okay, if it's not clear to you. Because you want to put it in the context of something you've done before.